HP's Oscilloscope and Pulse Generator Mobile Lab is truly a new concept in sales support. For the first time, our entire scope and pulse generator product lines are available in one convenient mobile display room. There are over 150 mainframes, plug-ins, and signal sources on board, set up in 23 separate displays, each capable of demonstrating the significant features of our product lines. This represents over $250,000 investment, which is made available to your customer at his own doorstep. Hi, I'm Joe Duntz from the Colorado Springs Division, and for the next few minutes, I'll be familiarizing you with this rather unique selling device. This mobile lab over the last 8 months has traveled some 20,000 miles and has been an unqualified success in visiting over 400 customer facilities. The equipment on board is divided into 3 areas. The front compartment features our lower frequency, general purpose, and portable oscilloscopes, XY displays, and our general purpose pulse generators. It includes the entire 140 system, the new 1700 portable oscilloscope series, the 1300 family of XY and graphic displays, the 1200 series, and the 8000 family of pulse generators. In the passageway between compartments are 2 displays highlighting the complete line of HP probes. The second compartment features the entire 180 laboratory oscilloscope line, including all recent product introductions. A variety of 1900 systems are used as signal sources. A videotape recorder and monitor are also located in this section, offering several 5-minute programs highlighting selected features and applications of HP scopes. At the rear are 3 1900 pulse system demonstrations: the digital programming interface, the multi-phase clock for MOS applications, and the pseudorandom bit sequence generator. Now, let's go on board and take a closer look at these instruments and demonstrations. One of the first things your customer sees as he enters the bus is a sign highlighting Hewlett-Packard's oscilloscope theme. Scopes are changing, are you? This question is intended to set the stage for your customer's visit through the bus. As he enters the front compartment, he immediately gets a very strong visual impression that HP is truly in the oscilloscope market. The entire 140 system is highlighted in this double bay console, including a display of all of the 140 plug-ins. The active displays in this area include the 143 large screen mainframe together with a 1415 TDR unit. The waveform being displayed is the result of the 1415 driving a demo stripline board. With this display, you can easily discuss the basic measurement technique and capabilities of time domain reflectometry. The written field training manual for the mobile lab gives details on this as well as all of the demonstrations. It highlights the prominent features of each instrument and gives some suggestions on demonstrating them. The second active display in the 140 area features the 140B 5-inch CRT mainframe, along with the model 1404 real-time vertical and the 1421 delayed sweep time base. The display is driven by a demo box behind this panel. Access is gained through the rear door of the compartment. The display is of 4 time-related digital waveforms and is a very excellent means of demonstrating the 140's capability in multiple-channel digital applications. The third live demonstration in the 140 area is the 8555B 8552A spectrum analyzer in a 141B variable persistence mainframe. By far, the star attraction in the front compartment is the 1700 series of portable oscilloscopes. This series is represented on the bus with the model 1700A, 1701A, and 1707A. Be sure to point out the logical front panel layout, the large CRT screen size and the brightness of the display at low rep rates. The 1707A's covers have been replaced with clear plastic ones to highlight the serviceability and ease of calibration in the 1700 series. Point out the use of printed circuit boards rather than rotary switches, the modular internal design, the location of the internal battery pack, and the relatively few number of internal adjustments. The 1700A is driven by an 8007A pulse generator located on the shelf immediately above. Emphasize that the logical front panel layout and the use of push buttons really simplifies display setups. Using the 8007 in the double pulse mode will also allow you to demonstrate the feature of trigger hold-off, often required in digital applications. The 1701A is connected to the model 8006A word generator, and here the emphasis is specifically on digital applications with a delayed sweep time base. Again, point out the simplicity and ease of operation, and be sure to demonstrate selectable internal triggering and delayed sweep operation. The 1707A is driven by two sources. One, a 3200B CW generator, used primarily to show the excellent triggering capability of the 1700 series, and the other, an 8012 pulse generator, to show the clean pulse response of the vertical amplifiers. This particular version of the 1707A includes the Option 20 lab package, which adds the features of Channel A output, calibrated delayed sweep, mixed sweep, external horizontal input, and external delayed sweep trigger input. This package adds only $125 to the base price. At the far side of the compartment is a display featuring the 1300 family of XY and graphic displays. The recently introduced Model 1311A 14-inch display is on top, and below it the 1330A and 1331A 5-inch XY displays. Unfortunately, we were unable to add any source on board which exercises these displays to their fullest extent. The Lissajou pattern you see is derived from two 3310s and two 204s located on the shelf beside the rack. The 1310 and 11 XY displays represent a significant contribution to the graphic display market. They use electrostatic CRTs, giving very excellent spot size, good large step jump response, and very bright character displays. They are significantly lower in weight than competitive units, use less power, and have an extreme price advantage at $3,000. Don't forget to mention that on all 1300 display products, Hewlett-Packard offers an OEM discount. Below the 1300 displays is a representative sample of our low-frequency line, the 1200 series. Active displays in this area will allow you to demonstrate their excellent high common mode rejection, variable persistence and storage, and dual-channel flexibility. At the very bottom of this display is Hewlett-Packard's lowest price scope, the 120B. Moving to the rear compartment, we find the complete 180 system featured. There are 12 active displays in this area, which will allow you to simulate most any laboratory oscilloscope application. The plug-in versatility of the 180 system is exemplified with a large plug-in display board featuring all the vertical, time base, and sampling plug-ins within the 180 family. The most notable attraction in this compartment is the 182 mainframe mounted on a pedestal. The clear plastic cover allows you to show the instrument's modular construction and ease of servicing. A short 5-minute videotape is available on board, which highlights the significant contribution Hewlett-Packard has made to the serviceability of their instruments. To the left of the compartment are three general-purpose demonstrations. At the top of the console, we have the new Model 1810 1 GHz sampling plug-in in a 181AR variable persistence mainframe. This system is being driven by the Model 1920 350 picosecond output stage of the 1900 system, allowing the clean frequency response of the 1810 to be shown. Point out that the two most important features of the 1810 are its price at $1,650 and its ease of operation. The second oscilloscope and pulse source provide an effective demonstration to your high-speed digital customers. The Model 183B mainframe with the 1830A, 1841A real-time plug-ins is connected to a 1925 word generator through a 1920 output stage. With this display, you can demonstrate HP's scope capability in high-speed digital applications, including the unique trigger circuits and delayed sweep operation available in the 1841A. The third display introduces the Model 1807A, a 35 MHz dual-channel vertical plug-in. With this instrument, the all-solid-state, reliable laboratory performance of the 180 family is extended to mid-frequency scope applications at a system price well under $2,000, including the large-screen 182 mainframe and a single-sweep time base. On the shelf between the two display racks are four 180 cabinet displays. The 180F militarized system exemplifies our capability in ruggedized scope design. Next to it is another new introduction to the family, the 180C mainframe, a higher writing speed version of the 180A. Its writing speed specification is 1,500 divisions per microsecond, some 3 to 5 times faster than the 180A. It's spec'd without fogging, using a 195 camera, ASA 10,000 film, and P31 phosphor. It's significant to note that this writing speed is compatible with the bandwidth of the 180 system. For example, with an 1802, a single shot, 3.5 nanosecond rise time, 6 division high pulse can be captured on film. Another plus feature of the 180C and its rack version, the 180D, is serviceability. The low voltage power supply is a modular plug-in type unit very similar to the 182. The complete module may be pulled out the rear of the instrument and operated fully exposed on the bench for troubleshooting. Yet another new entry to the 180 family is the Model 1808A, 75 MHz, 5 millivolt dual-channel vertical plug-in for the general-purpose high-performance market. Its most unique feature is a new thick-film input attenuator, which provides both a high input impedance configuration with low 12 puffs of shunt capacitance for general-purpose applications and a switchable, high-quality 50-ohm internal termination for accurate high-frequency measurements. The price of the 1808A is $875. The third display on the shelf is another 1810, this time in a large-screen 182 mainframe. A 3200B is available to show the unit's easy, stable triggering over a wide range of frequencies. For a pulse display, use the 800 picosecond calibrator output from the adjacent 183A, the fourth display. The output of the 3200B can also be used here to demonstrate the very excellent triggering capabilities of the 1841A. At the right side of the compartment, we have our high-frequency applications display. At the top is the Model 1580 narrowband TDR system, complete with 20 feet of waveguide mounted on the side of the rack. Wideband TDR, as you recall, allows the operator to characterize a wideband transmission system in distance versus impedance, However, wideband TDR suffers from many limitations when it's applied to a narrowband transmission device such as waveguide. The Model 1580 allows the operator to inspect his narrowband transmission system at a specified frequency of operation. And H33 8690B, located at the bottom of the rack, is used as the RF source. Effective demonstrations include the measurement of insertion loss, the length of the waveguide transmission system, and the location of some variable impedance discontinuities. The field training manual contains a complete discussion of this demonstration. The full 600 megahertz capability of the 183 system is shown in the next display, including the 183D mainframe, a Model 1831B direct access vertical plug-in, and the 1840A time base. This system is connected to a sub-nanosecond pulse generator behind this display panel, and the 700 picosecond rise time bandwidth of the oscilloscope is easily verified. The next two oscilloscope systems are used to demonstrate HP's 50 ohm and high frequency probing application story. These include the Model 181 AR mainframe with an 1802 and 1822, along with the 183B mainframe 1830 and 1840. The accompanying demo board is driven by a 1920 output stage. It provides probing points at 4 different source impedances and allows the operator to verify that the most accurate rise time measurement can only be made if he chooses a probe with the lowest shunt resistance and capacitance. A short 5-minute videotape is available on board to highlight the basic considerations in making accurate high-frequency probe measurements. Be sure to point out that HP is the only manufacturer that offers the widest selection of high-frequency probes for optimum accuracy. At the far rear of the bus, 3 examples of the 1900 plug-in system are available. These demonstrations strongly highlight the versatility available in a plug-in pulse generator. On the left is the Model 6936S digital programming interface and a 1900 system with a digital programming option. Unfortunately, space requirements would not allow us to have an active computer on board. But if you refer to the field training manual, you'll find that a manual demonstration of the system's capabilities will be adequate. The most significant contribution of the digital interface is that up to 32 mainframes of the 1900 system can be completely digitally programmed with only 1 I/O slot, a significant cost savings in computer hardware. The next display is for your MOS shift register customers. It features a Model 1934A multi-phase clock. This clock, together with a rate source, data generator, and output drivers, shows the complete flexibility of the 1900 in solving MOS shift register testing needs. The final 1900 display highlights the Model 1930A pseudorandom bit sequence generator. This demonstration will be of interest to your digital transmission and communication customers. The 1930 is capable of accepting serial data from a transmission line and comparing it bit by bit to a previously stored word or a predetermined sequence. It's also capable of generating variable length pseudorandom bit sequences, either automatically or under computer control, and it may also be used to encode and decode serial data messages. Well, that's what we call the newest concept in mobile labs. Unfortunately, we didn't have enough time to show you all the demonstrations possible, but I'm sure you can see with a full complement of scopes and compatible CW and pulse sources on board, there are a few applications you couldn't simulate. And I'm sure your customer will have the feeling when he leaves the mobile lab that scopes are changing. And with HP, they're changing for the better. They're more functional. They're easier to use and service. And they have the best price-performance ratio available.